Hello there. In this video we're going to do some applications of the circle theorems. I'm not going to be proving the theorems here, that will be in another video, but this is just, most of these are quick one-step applications. So in this first one we have two intersecting chords, and the theorem for that is the average of the two angles. So we see here that that's 140 over 2, so that angle is 70 degrees. And the next one over here, we have a couple secants. We have this exterior angle, and the formula for that is the far minus the near over 2. So on that one we're going to get 70 over 2, and x is 35 degrees in that one, which looks believable. The next one's a little bit more involved. So you have these one tangent and one secant, and it's still going to be the same idea of far minus near, but we don't know the angle of the arc measurement of the near yet. But we can figure it out because the whole circle's 360, and we got 190 here and 90 there. Boom. Boom. Okay, so this was, we'll call that near. Okay, so that's arc measurement of 80 there. And now, once again, it's actually just like this one, far minus near over 2. And we got 55 degrees for that one. Okay. Suppose this video got done a little bit faster than most of them, so let's talk about the y just a little bit here. This isn't going to be a foolproof. Now, there's a bunch of different ways to do these, but I like using the one where we draw in tangent lines. So here's a tangent line to that one there. And what we saw is, we actually proved this in class, that if that arc measurement there is 40, that arc measurement there is 40, and the angle x, because of the parallel line postulate, is mirrored there. And now that x is opening up to, as an interior angle. Oops, I don't want black there. Where's my better one? Let's go with hot pink. Yeah, that angle x is opening up to this arc of 140. It's an inscribed angle, so it's got to be half of it, 70. And you can keep using this parallel line idea that if I draw in parallel lines here, so there's a parallel line, if that's 30, that's going to be 30. And if that's x, because of the parallel line postulate, that's going to be x. And that x is an inscribed angle opening up to this arc, which the whole thing there was 100, but we took away 30 there. So the pink arc is 70, and x is half of 70. And this idea just keeps repeating throughout them. You go to this tangent line, draw in that again. This here is going to be x. This was 80, so the remaining part here was 110. Well, where'd my thing go? And that x is actually there at the tangent, so it's going to be half of that 55. So this parallel line idea, you get a lot of mileage out of it. You don't want to be drawing these in on every single problem, but it is the mechanic that you can use to generate these and prove it, which you may be required to do, is prove some of these theorems. All right, thanks for watching. Character and Scholarship for Life.